So thank you, Pauline. As you can all see, you should have something pop up that says this webinar will be recorded. My name is Claire Herbert, and welcome to the Last Drop Water Researchers Speaker Series. So for those of you who have not attended before, the Last Drop Speaker Series is brought to you by the University of Manitoba Sustainable Development Goal 6 Working Group. And our background is that in 2018, the University of Manitoba was named the United Nations Academic Impact Hub, or UNAI Hub, for Sustainable Development Goal 6, which is clean water and sanitation. And we are the only academic institution who holds a UNAI designation in North America. The SDG 6 Working Group at the U of M brings together established and emerging leaders who have a shared interest in freshwater sustainability and who work collaboratively with national and global partners to address the issues related to climate change impacts on freshwater systems at local, regional, and national scales. Our members include researchers from the Clayton H. Riddle Faculty of Environment, Earth and Resources, the Faculty of Agriculture and Food Sciences, the Faculty of Arts, and the Faculty of Science, as well as collaborators at the Center for the Advancement of Teaching and Learning and the Office of Sustainability. The SDG group's expertise spans multiple disciplines, including leading researchers from across humanities, social sciences, and STEM fields. And as I mentioned, my name is Claire Herbert. I work within the Center for Earth Observation Science, which is housed in the Clayton H. Riddle Faculty of Environment, Earth and Resources. I'm the data manager for the Canadian Watershed Information Network, and I'm the program manager and a researcher within the Manitoba Great Lakes program. And I co-chair this group with Nicole Wilson. So in this virtual format, we are coming from many different locations, but I want to acknowledge that I am located in Winnipeg, Manitoba, on the original lands of the Anishinaabe, Cree, Oji-Cree, Dakota, and Dene peoples in the homeland of the Métis Nation. In the theme of today's panel, I also want to acknowledge that my drinking water comes from Shoal Lake through the Winnipeg Aqueduct, which was constructed in 1919 at the expense of Shoal Lake 40 First Nations water security. So I invite you all to let us know in the chat what territory you're coming from. So today we have a talk by Dr. Zou Zou Kuzyk. But before we begin, I'll just go over some logistics. So we have enabled the closed captioning function, so please feel free to turn it on as you need it. As you notice, we are recording this event, and it will be posted on our U of M Sustainability YouTube channel after the talk. And the link will be put in the chat. And please mute yourself for this presentation. The presentation will last approximately 30 minutes. There will be a Q&A period at the end, and please feel free to put questions in the Q&A box, which will also be monitored. And for members of the audience who would like to learn more about or join our working group, you can visit us at the link Pauline will put in the chat because it's long. And there you'll also find on our SDG homepage a list of additional talks, which will begin again in January, as December will be a break period. So now, back to our speaker, which is Dr. Kuzyk. I will just give you a brief introduction. So Dr. Zou Zou Kuzyk is an associate professor in the Department of Earth Sciences within the Faculty of Environment, Earth and Resources at the University of Manitoba, and a researcher also within the Center for Earth Observation Science. She is interested in the biogeochemical cycles of carbon and other elements in northern, coastal, and continental shelf areas, and how climate and other environmental changes modify these cycles. So she works along the coastal marine and freshwater spectrum. She's worked along the North American Arctic Ocean margin, in the Churchill and Nelson River estuaries in Manitoba, the Lake Melville estuary area in Labrador, and she collaborates with researchers in Finland and Greenland. She also studies within her research group, studies within sedimentation processes and examining the role of particulate matter in controlling the fate of carbon, nutrients, and contaminants in coastal and shelf systems. And today she's going to talk about one of her projects, the Eeyou Coastal Habitat Project, which is a collaboration between the Kuzyk and Ehn research groups. researchers at other universities across Canada, and the Cree in a name I'm going to mispronounce, I apologize, Eeyou Istchee, and to study the coastal oceanography of East James Bay. So with that, I will pass it on to Dr. Kuzyk.
Thanks, Claire. I hope you can all hear me. And I'll be talking about not just my own research today, but as you can see at the bottom of the slide, there's a long list of contributors. I'll be speaking about a project where I was, I guess within the group I was called the integration lead. Essentially, I played a role of trying to lead a consortium of researchers from 8 universities across Canada and our partners in communities to pull together, I guess, a holistic picture of the coastal habitat of Eeyou Istchee and environmental change that's happened there. And as you can see on this slide, it involves the eelgrass and the geese and the rivers and estuaries along this coast. See here. I'll just start with thanking everybody. Thank you to the SDG group that invited me, and the goals, sustainable development of water. Even though I'm going to be taking us into the marine environment a little bit here, it's directly relevant to the sustainable development of water, freshwater resources. And I'll come back to that later in my talk. I'll also start by thanking all the partners. So there were 4 communities along Eeyou Istchee that were partners in this research: Chisasibi or Chisibi, Wiminji, Eastmain, and Waskaganish. And other community and regional organizations really played a big role as well. So you can also see on the slide here some of the logos from the Eeyou Marine Region Wildlife Board, Niskamoon Corporation that coordinated the research project, the Cree Trappers Association. So a number of regional and community organizations really have played a big role in all of this. So I want to put them up front. What I'm going to do today in the presentation is just sort of introduce you to it and the context and the way the project was initiated. The project framework. So this is a large multidisciplinary Cree-driven project, and the framework was really established before the researchers came to the table, which I think was a really important aspect of it. Then I'll walk you through the methods, the workflow, the ways we worked, and how we tried to move from very disciplinary teams to trying to produce interdisciplinary and even transdisciplinary research results. I'll briefly talk about the results, what we've learned about the system, and then a closing remarks. So here's Eeyou Istchee. This is the traditional territory of Crees in northern Quebec. The 4 communities, I've just put a little red arrow, the 4 coastal communities were the partners involved in this research. And of course, there's a long history of Cree occupancy along the coast, on the islands. For Chisasibi in particular, this was a community formerly known as Fort George, and they lived on Fort George Island. It started out as a seasonal gathering place for many people, and then grew into a permanent establishment. And then it had also a history with trading posts and Anglican missions and all of those factors. And here's an early picture of Chisasibi from 1979. The community was relocated from Fort George Island to the mainland and to this new community called Chesapeake, in association with the hydro development of the La Grande River. That's this main river system you can see in the center of this map image, with some of the large reservoirs. My screen is just very slow to advance here. I think it's going to go to the next picture. There we go. Sorry. So here I've broken the coast into 2 segments, from the northern tip at the entrance to Hudson Bay there, stretching down halfway down the coast, and then the right-hand panel is the southern portion of the coast. So you can see the communities of Wamingji, Eastmain, and Waskaganish down at the bottom. All of the green shading along this coast represents eelgrass. So this is a seagrass, and locally known as shepashk, and the numbers on the map represent Cree traditional trapline areas, coastal traplines. So CH refer to traplines associated with the Chesapeake region, etc., on down through the coast. So there is a rich tradition of occupying these coastal areas, making use of the resources. There are coastal authority figures. Each trapline along the coast has a tallyman and a goose boss, because the goose hunting is conducted along the coast in close association with these eelgrass beds, and a goose boss would coordinate that hunting. This was particularly in the northern regions. You can see near Chesapeake and Wamingji, very large expanses of the eelgrass. In the 1970s, this was described as the most extensive eelgrass habitat anywhere in North America. Just to, again, give a few more pictures so you can appreciate this, this habitat. You can tell these pictures are from the early 80s with these clothes. So the eelgrass is growing in shallow, sort of subtidal waters, not in the intertidal zone. Historically, it extended down to about 4-meter water depths, and the eelgrass would grow to be more than 2 meters in length. And it was just such an incredibly productive ecosystem. On the right-hand picture here, you're seeing eelgrass debris or wrack piled up all along the beaches. So from the turnover of these shoots and leaves, that material would be washed up and stranded on the beaches and would make these long piles, which sometimes Cree would use, for example, to temporarily put their geese in to keep them away from flies or keep them at a cool temperature, but it wasn't otherwise harvested. So just from what I've said up to now, you can imagine there's really rich Cree knowledge of this coastal habitat and of the eelgrass, where it's found and its condition. Let me see if I can get my slide to advance again. To tell you, the next few slides, I'll kind of walk through a little bit of a timeline to describe the context and the way the project was initiated. So as I've alluded, in the mid-1970s, when there was the prospect of hydroelectric development in the territory, natural scientists arrived and began doing a lot of documentation of the geese numbers, the eelgrass beds, where they were found, and there was really wide acknowledgement of just how important these eelgrass beds were for the geese. The geese are really central to Cree culture, and I've just used some artwork here that Natasja Mukash shared with us for the purpose of our pulling together this big study. I just love it because it captures this scene on the left here, the geese, as they are migrating south in the fall along this coastal habitat. The geese would land and spend long periods of time at the major eelgrass beds. And so the records from the 1970s show that even just one embayment would have more than 10,000 geese stopping there. So you can imagine this provided really a reliable food source and very good hunting returns for Cree, who would often be doing this hunting from their coastal camps. So I guess environmental change began quite dramatically in the late 1970s with the LeGrand complex, a fairly massive hydroelectric development. The next image, if my computer will advance to it, is just a map showing the sort of expanse of the LeGrand complex. So the Kaniapiskau River that used to drain to Ungava Bay was diverted partially in order to funnel it down through this LeGrand River system. Similarly, Eastmain and ultimately Rupert Rivers from southern James Bay, the flow was diverted north again to join this LeGrand River system and pass through the whole series of reservoirs and hydroelectric dams. Here's the community of Chesapeake. The last dam on that river system is about 35 kilometers upstream from the bay, just above the community of Chesapeake. So this large development began in the late 1970s, happened through a series there were multiple phases of development, and the last most recent phase has actually just occurred over 2009 to 2012. The Cree began noticing some changes in the eelgrass habitat close to Chesapeake almost immediately in the early 1980s. Again, if I can get my slide to advance, I'll show you another picture. Come on. Now I'm really stuck on this one. Here we go. It may have jumped a couple, but I'll pick up the story here. Let's pick up the story around 1982. This is when Hydro-Quebec began conducting monitoring of the eelgrass, and they focused in this area where near Chesapeake, where the river discharge had been increased quite extensively. Cree were noticing these some declines in localized beds, the trap lines closest to the river mouth, but it was not until the late 1980s when there was sort of a really abrupt decline. And so the Cree and Chesapeake alerted Hydro-Quebec that in the sort of gap years between 1995 and 1999, there had been massive changes in a number of the eelgrass beds. So here I'm showing a compilation of the Hydro-Quebec monitoring data from 1982 onwards, and just the above ground biomass of the eelgrass at these monitored stations. So in 1999, yes, Hydro-Quebec came in and did follow-up sampling, and they extended not biomass sampling, but a mapping of the eelgrass cover, inspection of how dense the cover was. They extended that all along the coast and determined that in that interval there had also been a decline in the eelgrass cover much more widely. So not just in the Chesapeake region where LeGrand impacts were known to have occurred, but also much more widely. To finish off the kind of timeline then, representatives from the community of Chesapeake, First Nation of Chesapeake, testified to the House of Commons Standing Committee on Fisheries and Oceans in the early and mid-2000s, because they were seeing not only these declines in the eelgrass, but really major decreases in the number of geese that were present. And so this led to the initiation of the project that has come to be called the Coastal Habitat Comprehensive Research Project. And the idea was that this project would address many of these gaps, try to look at the factors affecting the eelgrass, the factors affecting the geese, and the interrelationships between them. So Chesapeake really motivated this, and then the regional Cree Nation government signed an agreement with Niskamun Corporation and Hydro-Quebec, a joint funding agreement, and an outline of a structure whereby Niskamun Corporation would oversee the project, coordinate the project, and there would be a steering committee. So the groups I've already mentioned all take part in the steering committee. Hydro-Quebec, Cree Nation government, Niskamun coordinates it, and there are representatives from each of the 4 coastal communities at the table as well at the steering committee level. So this, I want to give the steering committee credit for really setting off this project in the right direction. Again, this is before researchers were directly involved. And they determined that they wanted the scope to be all of East James Bay. They set out a structure in which research would be conducted by 5 disciplinary teams. So here's where the kind of the academics come in: a river team, an ocean team, an eelgrass team, a goose team, and a team that would document Cree knowledge of the changes. The steering committee also indicated that Cree land users were to be involved in the research to the greatest extent possible. And they gave a directive to all the research teams that we would integrate Cree knowledge and science to try to address these overarching questions. So what are the main factors affecting the current state of eelgrass along the eastern coast of James Bay? And what's the impact of the state of eelgrass on waterfowl presence and consequently Cree hunting activities? So I just want to pause because this is sort of where the researchers came into the picture, presented with these large, complex questions that were going to require us to synthesize knowledge across disciplines, between disciplines, among disciplines, and to bring scientific knowledge and Cree knowledge together in some way, shape, or form. And I just want to pause on this. This is a diagram that was initially put together to sort of represent these 5 boxes, these 5 studies with these arrows, these one-way arrows that just nicely suggest that one study will feed into another, will feed into another, will feed into another, and at the end we will come out with some answers to these really complex questions. One of the first things I think that the consortium of researchers did was revisualize, take it back to the natural setting, and what this, the recognition that we needed to actually produce a much more holistic picture, and that was going to require, again, really interdisciplinary and transdisciplinary thinking, and stretch us out of our boxes. So the researchers had the question of trying to then develop sub-questions. How are we going to tackle this multidisciplinary these problems? How could we bridge the disciplines? And this is a little conceptual diagram of the multitude of questions, and the approach we took was to have several teams, if you will, address similar questions from their different perspectives. So, for example, this question of what factors influence eelgrass. This was discussed at length and examined using scientific methods by the sort of eelgrass team, and also discussed at length by Julian Idrobo, who was leading the Cree knowledge sort of documentation component and conducted lots of interviews with land users. So again, trying to bring together as much knowledge as possible about what factors were influencing eelgrass and how has that changed. So yeah, how has eelgrass biomass changed since the 70s? How has the environment changed since the 70s? A similar approach was used for the geese. What do we know about the state of geese, the numbers of geese using the eelgrass beds now versus in the past? And so we brought multiple lines of evidence, I guess, to these questions of the state of the eelgrass, the state of the habitat, the coastal oceanography, the clarity of the water, the nutrients that were present, etc., and the state of the geese. So kind of recognizing that we have this interconnected system, really an ecosystem or a social ecological system, because the Cree hunting, of course, there have been interactions between as the geese change, as the geese distribution changes, lots of impacts, and Cree having to adapt to those changes. I had to put in a few photos because really the wonderful part of this project has been working on the land, working together on the water, and learning from each other about this this coastal habitat, and extending that, sharing knowledge, I guess, whether it's in communities or whether it's out on the trap lines, whether it's hunting, whether it's doing different traditional activities. So that brought a richness, I think, and a warmth to the relationships, and a good level of communication in many cases. So as we came in the later stages of the project, we also, we as in the academics, we're coming at it with an awareness of expectations for researchers who are working in these research partnerships with First Nations, and without making this at the front or formalized in a structure of the research project, kind of in the background as a consortium, reviewing what we were doing and how we were doing it against these expectations, sort of in a way exercising checks and balances on each other to make sure that we were working in a way that was consistent with these expectations. So acting responsibly, I guess you could say. The workflow, we also asked ourselves, did the workflow in the project support principles like co-development and community engagement? And so I showed some of the photos there were also formalized ways in which we promoted community engagement through outreach events, and we had the opportunity to be present in the communities, even though COVID interrupted that. Working around COVID, we had we maximized, I guess, the time spent in the communities at various events, learning about their history and priorities, and letting them learn more about us as researchers and the kinds of work that we do. There were also formal co-validation sort of steps where the Cree knowledge that was documented was then examined by other Cree knowledge holders in the community, and these sort of iterative processes of sort of within each knowledge system, reviewing what had been learned and the interpretation of that data, and then bringing the two together to discuss and to see where we had common ground and where we had questions where things didn't match up. And I think this was really mutually rewarding in terms of learning from each other about different aspects of the system. This project, because we were given these specific questions by a steering committee, it was also clear that this science, this knowledge, this science and Cree knowledge, this whole collective knowledge base needed to contribute to informing policy, to some kinds of actions down the road, whether they are implementing monitoring, whether it's implementing some kind of restoration, whatever the actions may be that may be decided, we needed to produce a knowledge base that was going to be perceived as salient, as legitimate and credible to this wide diversity of both rights holders, First Nations communities, regional organizations, and industry in the form of Hydro-Quebec. So in hindsight, we've sort of analyzed the project in terms of the different roles that different entities played in contributing to the efforts to develop salient, legitimate, and credible knowledge. So, for example, the Cree Nation government, by initiating the project in the way that they did, that was a sort of an exercise that made sure that the project was going to be relevant to the needs of sort of decision makers as they saw it, right? So, as those decision makers were organized before we arrived, it was necessary for us to consider whether we were producing knowledge that would then meet their those sort of standards of the knowledge. So I won't go through these in detail. There were the steering committee, as I said, had really a diverse set of stakeholders at it, and in each community there were Niskamoon local officers, so members of the Cree First Nation who worked to do local coordination and formed, again, quite close relationships with researchers, and really helped also to facilitate the connection between researchers and other partners. And so here again, we looked at what were the actions of the researchers that may have contributed, or at least were efforts to try to make the knowledge more salient, more legitimate, respectful of diverse values and beliefs across all these different communities and the regional organizations. Each community is distinct and different and had different research priorities. At the same time, it was very important that the knowledge be credible, adequate both within the scientific knowledge system and that the Cree knowledge be credible within the Cree knowledge system. And so I think this led us to better understand the differences among the communities, and yet still we needed to tackle this sort of regional project that we were given. And so we became also more aware that there were tensions and trade-offs in having this regional context at the same time as working within communities and becoming quite aware of the community priorities. Another tension and trade-off, I think, came about because that the steering committee played this critical role in providing a framework for the researchers and again addressing the saliency of the results across Hydro-Quebec as well as local chiefs and councils, for example. But inevitably, I think some community members certainly perceived that the way this project was governed and the architecture was perpetuating some institutional relationships and, say, power imbalances, that were pre-existing. So again, the project was very much a product of the context and the history in this particular setting. And then there was this challenge, I guess, again, this tension between addressing local priorities, community priorities, versus addressing the research questions at the regional scale. So these are things we wrestled with. Nevertheless, I'm going to just say a little bit about some of the results. So I've already alluded to some of the environmental changes. Cree described to us, shared with us, especially Cree in Chesapeake, but also across the other communities, the changes they had seen from the hydro development, and then later as climate change came along, and possibly some interactions between them. So, for example, near Chesapeake, where the La Grande River was, where the flow was augmented so much, the Cree noticed very much so the freshening of the coastal waters. They noticed poor water clarity there near the river mouth, but also this was an aspect that was present that Cree described even in the other communities, in southern James Bay communities as well, that noticing the water getting browner and more turbid. There was hardening of the sediments. On the scientific side, I guess, a lot of the investigations focused on the La Grande River plume. Here's an image. The orange arrow is where the La Grande River discharges. And in the wintertime, under the ice cover, where the wind is not able to mix the waters, the freshwater forms a freshwater plume under the ice and really lowers down the salinity from a sort of normal background in James Bay of say 26, 27 down to below 5, levels below 5. And eelgrass is a marine species that does not do well at such low salinity. So at a local scale there near Chesapeake, we could document one distinct environmental change caused by the hydro development. A second change associated with the La Grande River is increased sediment erosion under the high flows. So during the period when the reservoirs were being constructed, some of the riverbanks were destabilized by the high flows. So they were undercut by the high flows, and there were a couple of quite massive incidents of riverbanks collapsing, releasing sediment, which was then carried downstream. Some of the riverbank eroded material settles out near the river mouth, but then during open water periods when there's waves, it can be resuspended and carried with the river plume. So we came to understand that not only the freshwater, but the sediments were much disrupted by the development. So those were changes that happened before the late 1990s, and there was a lot of consensus among both scientists and Cree knowledge that basically climate change arrived in this coastal environment in the late 1990s. And here are some graphs showing how exceptional the spring of 1998 was. There was exceptionally early ice breakup, and the sea surface temperatures, SST, in June reached unprecedented warm levels. And this was an event that we have come to believe was quite impactful again for the coastal environment. Sort of moving on from that period of time, since 1998, in the last 20 years, there has been a trend of browning. So many of the rivers are draining wetlands and really tea-colored water. So it's dissolved, colored dissolved organic matter that's being carried in with the river system. But in the offshore waters of James Bay, there are trends of increasing levels of this brownness over the last 20-year period. And it is also most intense in the spring. So what we have come to put together is that there have been multiple factors affecting the eelgrass health, and some of them are operating at different scales. Some of them are acting at or have acted at the scale of all of East James Bay. On this scale, there are reports of increased turbidity of the water, so lower water clarity. There's been the warming of the coastal waters with climate change and earlier ice breakup. Near the East Main River, which has diverted flow, there have been there's a localized impact, and in the northernmost sector near Chesapeake to the coast, we again have this modified freshwater discharge, this fresher plume, and the sediment transport. The effects on the social ecological system. So I've said that the geese and the eelgrass meadows are very tightly tied together. Tens of thousands of geese would stop in the bays that had the dense, rich eelgrass meadows. And this was fundamental for how the traditional fall goose hunt was organized. The Cree would not disturb the main collection, these massive flocks of 10,000 birds. But at high tide, when small flocks would break off and fly to other types of habitat, say berries out on the islands, that kind of thing, hunters would be distributed in order to capture and hunt those small flocks. And so under these conditions, the main flock of geese would remain for weeks at a time, and it was a really productive goose hunt. So with the breakdown of the functioning of this sort of eelgrass meadow and goose ecosystem, there have been really profound impacts on this traditional fall goose hunt and everything associated with it, all the cultural traditions associated with it. Of course, other factors have been coming into play with the geese, and this is recognized by everyone, that the agriculture in the south and the increased numbers of these large Canada geese that don't mind hanging out in cities like Winnipeg, etc., and are all around the Great Lakes. There are 4 different populations of Canada geese that move through the area and could be hunted, and there's been a shift. The short necks that were traditionally harvested, their numbers along the coast are way down, and these numbers of these large long neck geese, which even taste different because they are not tied to feeding on the eelgrass. Their numbers are up. So there have been really profound changes from the eelgrass and the coastal habitat through to the geese and to the hunters as well. So often, I guess part of the other thing we looked at is why has the eelgrass not been able to recover? And we have a conceptual model that looks sort of like this little cartoon that I have up in the upper right-hand corner. Eelgrass is a self-stabilizing member of it's sometimes called an ecosystem engineer. It calms the waves and stabilizes sediment. And so when eelgrass is healthy, it's stabilizing and creating a great environment for more eelgrass to grow. The water remains clear. And our understanding is that these early impacts of hydro, the eelgrass were so healthy at that time, they were largely buffering those impacts. They were trapping a lot of the sediments that were getting released. But then in the late 1990s, when we had MHW, when we had marine heat waves, we had this climate change stressor, which, on top of the preconditioning, this marine heat wave, it held back eelgrass growth and essentially shifted this ecosystem from one stable state to an alternative state. Now the eelgrass is sparse and short, and it's not effective at calming the waves. And we have low light conditions. We have the seabed being stirred up, sediment being stirred up off the seabed. And this is not good for eelgrass growth and not good for the recovery of the eelgrass. And so we have a lagging recovery. On the bottom of the slide, I've just said that we wonder whether this is a particularly important set of feedbacks in James Bay, because this is part of the Hudson Bay lowlands where there's naturally a lot of fine-grained muddy sediment and naturally isostatic rebound, so falling relative sea levels. It's an environment that's naturally prone to sediment resuspension as the deep seabed is being lifted up into shallower water. Just to close now, I just want to say that what we've learned, I think, overall is we're seeing an example here of how when climate-related changes stress a system that's already been modified by past local activities, local development, the latter, that development can really determine whether these populations and ecosystems persist or fail. The idea that the system was preconditioned for these massive changes, and so what could have been a temporary setback from the marine heat wave instead led to really massive change, and the effects cascaded through the social and ecological system. And I think about how sustainable development of water resources faces new challenges. Well, in the 70s, when the environmental assessment work was being conducted, they did not foresee climate change. They did not foresee warming trends. They did not foresee sort of all these extreme climate events. They did understand that if anything were to happen to the eelgrass ecosystem, that it would be devastating. But they did not anticipate that because they were not seeing this rise of climate change. And so now we are in a different context, of course, but I imagine it's still really, really difficult to evaluate potential impacts because there are not only warming trends, but again, there are these extreme events in some years. So it's very complicated. But I think that bringing these, the Cree, the knowledge of the Cree land users of this coastal habitat was so far beyond the scientific understanding in the 70s, 80s, and only through these last few years of this collaborative research have we sort of gotten the scientific understanding anywhere near being able to sort of bring new insights to the table. So I think that really we need to address these challenges with multiple knowledge systems. So we'll see what the future holds. We're in the process of, I'll be going to communities in early December to talk about the next stages. We've given our final report on the integrated results. You could find if you're interested in more information, you can find it at either of these sites here. Thank you again.
Thank you so much, Zou Zou. I'm trying to find my camera. That was so informative and amazing. So I guess I will open it up for questions first. Anybody have a question? I cannot see them. I think if you can just put them either in the Q&A or the chat. Now I can start. I have a question. Well, I have many questions, but my first question would be, so do you have any advice? Like, what would you say? I mean, you went over it really well, but if you were providing advice to someone about how they could best work with communities, what were the key lessons that you learned in terms of trying to work with different communities on issues of concern to them?
Well, I think, Claire, that you hit on it right there, that because the communities could express to us what their concerns were, what their priorities were, really then we had to ask ourselves, okay, what tools, skills, knowledge can we bring to the table to try to address these questions? And it flowed very naturally from that. I think, as I alluded to, if there was a tension in the project, it was more because we both had regional questions coming down, as well as each community, and each community is different and distinct, and even sometimes each trap line has had a different experience and sees it differently. So I think that was the challenge, was to try to apportion time and energy, within a project that has very limited time, money, where to put your attention. But I think that that's what was really good about, by being in the communities, it kept putting community priorities sort of back to the top, which is really important.
Great, thank you. And I'm going to read these both to you because I think they're kind of related. So Emma has a question. Could you explain how climate change impacted CDOM? And Ricardo says, great work. Can you elaborate on the climate change attribution of the browning of waters and how you isolated other factors?
So the browning of waters is basically it's the scale at which it's occurring is really the most the scale and the timing, but really the scale at which it's occurring is why we loosely attribute it to climate change. There's still some controversy, scientific controversy about, first of all, whether natural rivers have increased their discharge is actually not known. So a couple of different research efforts looked at this in different ways. There are limited records going back 20 years of river discharge to the region. Based on those records, it doesn't look like the actual volume of discharge has increased from these rivers. You know, in some of the large-scale compilations that have been done where the region is included, like in a larger scale survey, they've suggested there have been also, again, kind of conflicting results. Some people find that river discharge has increased, from natural undeveloped rivers, that the discharge has increased in the last 20 years, and other studies will find that it has not. And it's basically the area that the hydro development has modified the hydrology on such a scale that I think it is exceptionally difficult to tease apart what's due to development and what's due to sort of climate change or climate variability. So maybe this browning of the offshore waters is due to increased river discharge, but there are other competing hypotheses. There's globally, we know that boreal rivers have undergone a browning. That's not been demonstrated for northern Quebec for these specific watersheds. There aren't really the data sets to demonstrate that, but throughout Scandinavia, browning of boreal rivers is a really well-known phenomenon, and there are a few examples in Canada, I think, as well, where it's been shown. So it may be that there's not more flow from the rivers, but just the water that's coming out is browner. Or a third hypothesis is that it's processes out in the bay. Normally, you know, there's a sort of a sequence of when the river discharge peaks in the spring, and when does the ice melt that's in the region? Because when the ice melts, when all the sea ice melts, it's introducing a perfectly clear, colorless freshwater source. So if you had different combinations of that ice melt and the river water, you're also going to change how brown is that water. So I'd say the satellite data, that was from satellite data, that CDOM, that browning. So we believe it's a real, that's a confirmed kind of observation, but the causes of it, well, we've got work to do.
Great, thank you. And Ricardo had another question. Another question about the long-term sustainability of traditional hunting. What would be the cost of bringing the system back to its quote-unquote original state?
You know what? No one even knows really if there's any going back. This has been the real question that the Cree land users want is, what they want to know is, if we got the eelgrass back to the original state, would the geese come back? And no one, I guess the different biologists have answered that differently. I mean, one biologist from the Canadian Wildlife Service said, you know, probably it'll bring more geese, but you know, no one is quite ready to. You can't guarantee anything, I guess, in these ecosystems. Lots of other things have changed in the meantime, and for example, these long-necked geese that are now around so much, they are not the ones that were tied to the eelgrass habitats. So there have been so many changes that it's really hard to know about whether the geese could ever come back, or will ever come back, you know. Now, the eelgrass does provide a lot of other ecosystem services, as we often call them, right? A lot of other functions in this ecosystem, like it's still fish habitat and invertebrate habitat. When eelgrass ecosystems are healthy like this, they can capture a lot of sediments and therefore carbon. So there are a lot of other really important functions that, right, they're helping to minimize kind of coastal erosion. So there are a lot of other things that would be improved by if the eelgrass would come back. But right now, no one knows right now if it would even be feasible to try to facilitate the recovery in some locations or not. That hasn't been done. We don't know if it is feasible. That might be part of the next sort of phase of work. If there are communities or trap lines where the land users and the tallymen are really want to try to attempt that. If there's a push for that, I could imagine there may be some support to try to do that, to try to facilitate some recovery. But there are quite a few questions still about that.
Great, thank you. And Steph McLaughlin has 2 questions. So the first one is, fascinating talk, thank you. Lots of parallels between this work and our own through Waskitan in Manitoba. One ironic element of this situation is greenwashing, and how hydropower has reinvented itself as clean green and is climate smart. Assuming that Hydro-Quebec is in part funding this work, has this undermined the kind of science you are conducting, or how the outcomes are managed or played down by the Crown Corporation and or politicians?
That's an interesting question, something we've thought about and asked ourselves. And I think that the way this project was set up, it was, it was decided from the beginning that it was, really important to have Hydro-Quebec at the table participating on the steering committee, and right alongside the community members, right, representatives from each community and representatives from the Cree Nation government. And so, as you can imagine, there are really sometimes intense discussions that go on at that platform, sort of in that platform, in that space, at the steering committee level. One of the things that was also really important, and it was written into the original framework, is academic freedom, right? That all of the researchers, although we share our materials, we share our papers, we share our reports with the steering committee, with local chiefs and councils, with everybody. We share all those materials, and everybody is welcome to provide comments and feedback on those materials. There is no obligation, there is no requirement that we make any changes if they're requested, by whomever. So I think maintaining the academic freedom was a really fundamental thing that I give Niskamun Corporation a lot of credit here. They have some really excellent people that have a lot of experience, and could have sort of anticipated, I think, many of these challenges. So they really put the framework that they established was really fundamental for this project being able to roll forward like that. So outcomes. So I would say outputs, from the research are really very much reflecting the independence of all the researchers who were involved in the project. But in terms of outcomes and what is done with this knowledge and where it goes next, right? That's these things that are, these things get out of the range of our control, and and they also really get out of the sphere of what we influence, and they go out into another sphere. And there, I think we, to the extent that the researchers have influence, we will continue to remain engaged and to try to ask the right questions, ask questions that would contribute to maybe some different outcomes from the future. But we're not in control of really how those things will play out. Sorry for the sort of answer.
Well, thanks. I'm going to flip the list here. So I think Stefan was responding to your answer. He said, interesting. In our case, the community partners in Waniscatan decided to exclude Manitoba Hydro because they already had enough influence and would undermine our role when it came to advocating for change.
Mm-hmm.
And he has another question, was also curious about some of the tensions surrounding this project and its governance, which are often inevitably when you take multi-actor approaches to research and environmental management. To that end, what is the composition of the steering committee, and how much influence do rights holders have over the project, and especially how prominent a voice are the traditional harvesters in this process?
Mm-hmm. So yeah, the composition of the steering committee is so Hydro-Quebec, Cree Nation government, and representatives from each community, each of the 4 coastal communities. Then there are a few other bodies, like there's an expert, a goose expert from the Canadian Wildlife Service, federal government. There are the Eeyou Marine Region Wildlife Board has seats at the table there as well. Who am I forget? I don't think I'm forgetting anybody. But so in terms of that large scale review and in terms of providing feedback, it is coming from, quite a diverse group of people. I think what I was trying to communicate here is that researchers, a framework did a lot about setting things off down the right path. And for instance, by ensuring that researchers would prioritize Cree involvement, like the methods that would be chosen, the ways in which. So for example, rather than visiting a remote site by helicopter, researchers would visit that site, maybe making a 4-hour trek, in the Cree canoe with land users. And maybe, rather than sort of, so with a helicopter, you picture they might, fly in, fly out and sort of spend 2 minutes there. There was a real effort to do the coastal research by, following kind of the way that the Cree would travel on the coast themselves. So, staying overnight at their camps. And I think that really was important because it did bring the Cree view of the environment, the Cree knowledge of what had changed and how things were before. It made sure that it's a large number of researchers coming from many different backgrounds, but it was really eye-opening for the ones who had had no experience in that coastal area before. You can't, after one trip to a remote camp and coming back, your appreciation of Cree knowledge is right up here because they have, they've shared, the Cree land users were really open about sharing their knowledge with us. So I think that helped to, again, kind of bring Cree perspectives and Cree knowledge back to the center of what was being discussed. But there's a responsibility on the researchers and on this consortium to keep each other centered on that, and to, again, sort of try to live up to the expectations, right, for responsible research in these sort of communities. And so I think by kind of circling back to these expectations and to, holding each other as a big research consortium, trying to hold each other to meeting these expectations and to the community priorities, I think there was a sort of a self-governing loop in there. So anyway, those are the efforts that we made. Time will tell, I suppose, right?
Very cool. Thank you. And Stefan just says, thanks. Amazing presentation and really thoughtful responses to our questions.
Thanks.
I absolutely agree. Yeah, thank you so much. And that pretty much brings us to our time. So I want to thank you once again, Zou Zou. That was amazing. You can see her research on the links, everyone, that were posted in the chat and are also available via the CIOS website and the CanWin website. And so thank you again, everyone, for attending. We have more talks in the speaker series, but they don't start. We're taking a break in December, so we start back again in January, where myself and our collaborator from the Manitoba Métis Federation, Phoenix Coombe, will be talking about creation of the Manitoba Métis Federation Citizen Science-Based Weather Station Network for real-time decision-making. And Anamike, as well as everyone else, says thank you very much again, Zou Zou, for that great presentation. And I wish everyone a great day and a great week. Cheers.